Hi, my name is Adam Smith. I am the Cellular Product Manager for LitePoint Corporation. Today I'm going to talk to you a little bit about cell phone manufacturing test cost. And specifically, I want to look at changes that are happening in our industry and in technology that are driving manufacturing, and specifically how we can address the cost of test for manufacturing these phones. So I'd like to start with an anecdote. Not so many years ago, the cell phone space was a lot like a private beach, where there were only a few players and it was vertically integrated in such a way that it was very difficult, a high barrier for entry for other players to get into this space. Now, in the last few years, we've actually seen a trend that happened in the 1980s in the PC computing space, and that's standard platforms. So a platform like Android with a chipset, like a Qualcomm or a MediaTek chipset, has now allowed a reference platform for almost anybody to get into this space here. So our little private beach has gotten extremely crowded now. Now this is exciting for the consumer because it gives you variety in the products and allows you to get products to market very quickly. Now, the downside to this is that differentiating these products is actually quite difficult because we can't differentiate so much on form and function as much as now it's around price. And so very much we want to focus on how do we reduce the cost to make sure that manufacturers stay competitive. Because of these standard reference platforms, we're now seeing extremely large growth in the smartphone space specifically. So this year we're going to see roughly 1.3 to 1.4 billion total cell units shipped this year, and roughly half of those are going to be smartphone, which is incredible growth over previous years and represents about 25% compound annual growth. Now with that introduction of the smartphone as a mainstream platform, a lot of technologies are being crammed into the phone, and so the product complexity is increasing greatly. So on the cellular space, now with the advent of 3G moving to LTE, we now have more bands, so 40 plus bands in LTE alone. We now have TDD and FDD standards being introduced. We're now starting to see MIMO technology, or multiple input, multiple output, make its way into the handset. And what this allows us to do is have improved sensitivity in the phone as well as improved data rate. On the connectivity side, on the Wi-Fi, now we're starting to see dual band Wi-Fi. We're now going to get higher data rates with our handsets. In the next year or two, we're going to start to see the 802.11 AC standard, so extremely high data rate within the handset. On location-based services, GPS is a standard feature today. We're rapidly starting to see GLONASS technology make its way into the phone. As the Compass and Galileo systems start to come online, these will also make it into the phone over the next couple of years. And then lastly, on the other connectivity side, Bluetooth is a standard feature in almost every smartphone today. We've now made a transition towards Bluetooth Low Energy, and we're now starting to see Near Field Communication, or NFC, make its way into the phone to introduce more features to the consumer. On the horizon is the potential for some of these extremely high data rates, so wireless docking or wireless video technologies make their way into the handset as well. And this will be something that needs to be addressed in a cost-effective way. So as we add more of these technologies into the handset, if we use traditional test methodologies, the test cost is going to just naturally start to creep up, and not at a linear rate, at an exponential rate as more things are added to the phone. So let's look at 3G as an example. As we transitioned from 2G to 3G, we roughly doubled the amount of test content to be tested. So we had to go to a new type of test methodology, where we went from traditional signaling-based test to non-signaling-based test. And this allowed us to talk directly to the chipset and reduce the test times by about 1/2. So the increase in test content was offset by the reduction in test time. Now looking forward at LTE and beyond, this is not going to be able to hold true if we use traditional methodologies. And the reason for this is we just have more frequency bands to deal with, particularly as we look at this from a global basis, more antennas on the phone, and in particular, we've got more configurations to be tested. So we've got more data rates, more configurations, and it's just going to add about 5x to 10x more content to test. If we don't do something different, the cost is going to continue to go up at an exponential rate. At the same time, the price of the phone is coming down extremely fast to reach mainstream consumers. If we don't do anything about the cost curve, with the price coming down, it's going to put a lot of pressure on the margin for these phones, and it's going to be very difficult to make money in this manufacturing industry. What we need to do is think about this a little bit differently and do something differently to bring the cost curve down so that we can bring the cost in line with the price of the phone. The challenge now is how to reduce the cost while we increase the capacity to meet the demand of the growing smartphone market. So the first thing we could possibly do is limit the amount that we test on the phone. Flat out, don't test as much. That obviously risks the quality of the product. We can't verify that the product quality is good enough for the consumer. To meet the capacity requirement, we can just buy more testers and do the same thing we've always done. But that obviously doesn't address the cost side of the equation. So really what we want to do is look at a new test philosophy altogether and improve the efficiency of each test cell in the manufacturing environment. And the way that we believe the best way to do that is through multi-device testing in parallel, using multi-DUT or device under test methodologies. Multi-device testing can be imagined like some cell phones coming down an assembly line on a conveyor belt. If I have a test cell producing roughly 25 units per hour, and I've got a production capacity of 100 units per hour, I'm going to need 4 test cells in order to meet that production demand. In a multi-DUT environment, imagine I have a wider conveyor belt where I can get more phones out in the same amount of time. So rather than 25 units per hour, each test cell I can now get 50 units per hour or more. So for the same 100 unit per hour requirement, I need half the number of test cells. And a test cell is not just capital cost. There's both an operating side and a capital side of this. So by moving to a point where I can get more efficient with the test cell, I reduce the number of test cells that I need, the number of operators I need to pay, the amount of floor space in the factory, electricity, test fixtures, PCs, etc. So it's both an operating side and a capital expense side that we're addressing by doing that. So what we want to do is increase the throughput of the test cell, which by extension increases the efficiency of the test cell, which allows you to optimize your capital investment. How much is throughput worth? To borrow the phrase time is money, I like to say time is actually currency. Because what we see in the test cell is that capital cost has decreased year over year, yet labor cost tends to go up. The overall test cell is actually being dominated by operating cost at this point. So if we really want to reduce the cost of test, we should address the bigger piece of the pie, which is the operating side. Where we need to focus is on the efficiency of the test cell. And the metric I like to use is units per test cell per year. If we can improve the throughput of the test cell, we can dramatically lower cost. To apply some numbers to this concept, let's take an example of a 3G handset. And let's say we have a manufacturing production requirement of 10 million units in a given year. If I look at it, a common example that we have here, in a 1-DUT situation, we've got about a test time of 113 seconds. Whereas if I address this with 4-DUT test techniques, that averages out to about 43 seconds per device. Following the math through here, what this means is that if I have to produce 10 million units in a given year, with a 1-DUT methodology, I have to buy 180 test cells. Whereas with a 4-DUT methodology, I have to buy only 70 test cells. So this means 1/3 the number of test cells, 1/3 the number of operators, and this dramatically addresses the operating cost for manufacturing that phone. Carrying that all the way forward, what this means is that I save some capital money, about $600K in this example. But really my most dramatic savings is on the operational side of $2.7 million in a year. As we can see, multi-DUT test enables a very large benefit in economic performance. However, it does present some technical challenges that need to be overcome in order to successfully implement this in a production environment. The first challenge that it produces is that you could potentially have the increased complexity on a test fixture. So instead of a single device to be tested, we now have multiple that need to be interfaced to. Additionally, this fixturing could introduce the possibility for devices to talk to each other and affect each other's performance. Related to that, we want to make sure that if one device fails, it doesn't affect the other performance of the other devices and reduce the yield. On the solution development side, we also don't want to reduce our time to market because we made a more complex system. So we need to make sure that implementing multi-DUT is easy to do. And lastly, from a throughput point of view, there's just flat out more data to deal with, so the test equipment needs to be able to deal with this in an efficient manner. Let's look at some of these challenges individually. On the test fixture side, traditionally with single device testing, we had a direct connection between the device to be tested and the test equipment. As we look in the multi-DUT environment, we now have to get multiple devices back to that same piece of test equipment. And this introduces some questions. Who's going to manage the calibration of what's between the device and the tester? How do you control the switching between there? Is this going to be a robust production solution? How do you handle retest and failures? And is crosstalk going to be an issue on this fixture? Ideally, what we want to do is integrate a lot of this complexity within the test equipment itself. So we want to integrate the multi-DUT signal routing within the test equipment, and then automatically manage the calibration path losses for the user, simplifying this, making multi-DUT test more like single-DUT test. Also, because we can synchronously control the devices to be tested, we can ensure that they don't talk to each other, so we know exactly when which DUT is talking. Lastly, because there's a lot more data to be dealt with here, we want to utilize some multi-threaded processing out of the powerful processing that's within the test equipment. But we want to make sure we do this automatically for the user so that we don't increase the complexity of the test solution. Let's turn to time to market considerations. Ideally, what we want to do is make sure we don't suffer time to market just because we move to multi-DUT. So from a test program development point of view, we need to provide turnkey solutions that enable customers to get into production as quickly as possible. For non-signaling, this needs to be achieved by producing a solution that talks the native language of the chipset. And what we do is provide these turnkey solutions that allow customers to get solutions into production in days instead of weeks or months. The idea here is that we want to make multi-DUT testing very much like single-DUT testing and not add complexity to the test program development process. LitePoint is a pioneer in the manufacturing test industry with the industry's very first 4-DUT and 8-DUT parallel test solutions. We've done this by thinking about multi-device testing from the ground up, and we provide not only the hardware required to do multi-DUT testing, but also the turnkey non-signaling solutions for customers to get into production as quickly as possible. For more information regarding all of LitePoint's products, please visit our website at litepoint.com. Thank you very much.